So this one is page number 109 for classified paper 6, question 7, topic experimental techniques. So the first thing, test on solid E. The first one, about half of a solid E was placed in a test tube and we heated gently. The steam was given off and the condensation appeared. Whenever we supply heat energy to a solid and we observe a condensation form, so what gives what
It
this
is a
give an idea?
hydrated solid,
Yeah.
hydrated crystal.
Yeah, so this give an idea that E is hydrated, means it contained water of crystallization. Like any salt is there, dot XH2O, like hydrated salt is there. That's we get an idea about from its whenever a condensation forms. So simply this give an idea it's a hydrated salt. The second one, the remain of solid E was dissolved in a distilled water and the solution was divided into 4 test tubes. So what we did, we dissolved this and we have 4 samples, 4 different test tubes are there. About 1 cm cube of a nitric acid followed by silver nitrate. What is this test for? Nitric acid and silver
Halide
nitrate.
For
ions.
halides.
Test
So
for
no
halide.
change means it is not a halide. Solid E.
Yes. So chloride, bromide, and iodide. That this is a test for halide actually. So if there is no visible change, means it does not have any halogen or no halide is there. Then, and you can check from test for ions in exam, it will be there in paper 6 with you. So you can check if you want to test the halide ion, chloride, bromide, or iodide. So what we do, we add nitric acid followed by silver nitrate, and there is no visible change. So it shows that halide is absent or no halide is there. Then nitric acid and barium nitrate. This is test for what?
Sulfate. SO4 2 minus.
Sulfate ions.
So this is a test for sulfate ion. So it give a white precipitate. It means that there is a sulfate present. And excess of aqueous ammonia was added, a white precipitate form. So if we add aqueous ammonia and there's a
Most
white,
likely aluminium if it does not dissolve.
yeah. So you can see when we add sodium hydroxide, when we add aqueous excess of aqueous ammonia, not sodium hydroxide here. Yeah, aqueous ammonia was there. So when we add excess of aqueous ammonia, the white precipitate are insoluble in excess. So this gives an idea that it is aluminium. So this test give an idea that this is aluminium, like this white PPT. Give an idea aluminium is there. This white PPT give an idea it's a sulfate. Then sodium hydroxide is there. Dropwise white precipitate will dissolve to form a colorless solution. So if it is an aluminium, there will be a white PPT and it will dissolve to give
It
a
will
colorless
dissolve.
solution.
So it is aluminium ion.
So this confirms that it is aluminium ion. Then the product of test 5 was warmed gently. So like sodium hydroxide was added and we heat it. Whenever sodium hydroxide and heat, a red litmus turned blue.
Ammonia is, it confirms we have NH4 plus ion.
Yeah. Ammonia is released as a gas. So this also confirmed that there is ammonium ion as well. Because adding a sodium hydroxide, when we add sodium hydroxide and heat, if a gas given off, you can see ammonia produced on warming, adding a sodium hydroxide. So this same thing happened. When we add sodium hydroxide and heat, ammonia gas is released. So state the conclusion that can be drawn from
Hydrated salt.
So this give an idea. It's
Mm.
because test 1 was when we supply heat
Contains
energy.
water of crystallization.
So hydrated salt or contain water of crystallization. And what conclusion, state the conclusion that can be made from test 2. So test 2.
No halides ions.
So there is no halide because test 2 was when we add silver nitrate, nitric acid followed by silver nitrate. There was no visible change or no reaction happened. This give an idea that there is no halide present or no halogen is there. Then identify 3 ions. So what are the ions?
Aluminium, sulfate, and ammonium.
Good. So this give an idea that there was sulfate ion, This gives an idea there is aluminum ion. This confirms the idea that there is aluminum ion, and this gives an idea there is ammonia gas is released, but the ion which is present is ammonium ion. So the three ions which are present, ammonium, sulfate, and aluminium. So there is an aluminum ion, there is ammonium ion, and sulfate ion.
Sir, can we write it with words or only by
You can
symbols?
write both ways. You can write as a symbol. You can write that the solution contain aluminum ion, it contain ammonium ion and sulfate ion, or you just write the formula for the ions. That is also fine. You will score the mark for both. Then next question, test on solution F. Solution F is aqueous sodium hydroxide. Complete the expected observation. So sodium hydroxide is there. If we carry out a flame test, there's a sodium
Yellow,
ion.
yellow flame.
So it will be yellow. The remaining of a solution F was divided into two equal portions. To the first, we had a universal indicator. What will the color of universal
Blue.
indicator?
It will
Purple.
be blue.
Yeah, blue, purple, violet, acceptable. The second portion of F, approximately 2 cm cube of a copper 2. So when we have a copper 2 ion and we add sodium hydroxide, as you can see, if we have a copper ion and
We
we
will
add,
get a light blue precipitate.
yeah, so which will be insoluble in excess.
It will, we can say, light blue precipitate remains.
So blue precipitate, light blue precipitate, and approximately 2 cm cube is added. So it's not that too
We
much
need to,
quantity. If it was in excess,
we
then we
need
can,
excess for saying remain.
yeah. So this was question 7. Then question 8 is also about the experimental technique. Most of the questions are related to identification of the ions. Then solution A and B were analyzed. Solution A is copper 2 bromide. So it contained copper 2 ion and it contained bromide ion. Test on solution A is done. Solution A was divided into approximately three equal portions. The end of a piece of a wire is dipped in the first portion. The end of a wire was placed at the edge of a roaring Bunsen burner. And observation, what is the flame
So
color?
it will
Basically,
give
Blue-green,
blue-green
blue-green
flame.
flame for COP Cu2 plus.
yeah, so it will be blue-green. And that is also given here. You can see the flame colors. For copper, it is blue-green. Then to the second portion, we add aqueous ammonia was added dropwise until in excess. So first, when we add
If it
aqueous
is in
ammonia,
excess, we will get light blue precipitate which dissolves to give a royal blue
so
color solution.
so you can say blue PPT first with dissolve to give royal blue solution or inky blue solution. So as you can see here, for whenever aqueous ammonia is added with a copper ion, so it will be a light blue PPT soluble in excess. This will give a inky blue or a dark blue or a royal blue solution. So that you have to write. To the third portion of a solution A, 1 cm cube of a nitric acid followed by silver nitrate. So nitric acid followed by silver
Green
nitrate is
precipitate.
Test for halides.
test for
It will give
halides.
vacuum
Which
precipitate because
For
bromide.
bromide, we
yeah,
will have
because
green
bromide is there, so it will, as a result, it will produce cream precipitate. Because all these tests, the negative ions, the chloride, bromide, iodide, we test in the same manner. But the only difference is the observation. With chloride, it will be white. With bromide, cream, and with iodide, it will be yellow. Solid B. Solid B was, yes, you can write PPT. That's right. You can write PPT. Instead of writing full precipitate, You just write PPT. What we write for part C? For part C, we will write cream color precipitate. Why cream color precipitate? Because in the beginning they mentioned this is a copper, the salt which contain copper 2 and bromide. And bromide ion with nitric acid and silver nitrate give us the cream color precipitates. The cream PPT. Then solid B was added to 15 cm cube water in a boiling tube, and a bung was placed in a boiling tube and it was shaken, dissolved. And to the first portion, B was tested using a universal indicator, paper turned blue. So what this given an idea?
From 8 to 10 pH.
Yeah.
Yes.
Or it is an alkaline solution. That is one idea we got. Then to the second portion, sodium hydroxide was added, and until it in excess, the white precipitate form which remain in excess. So
If it remain, we have calcium, Ca2 plus
so which one,
in excess.
which positive ion white precipitate remain? It cannot be aluminium because so it is calcium, because white PPT is there, as you can see, white PPT which is insoluble in excess. Aluminium also give white PPT, but it dissolve in excess. Zinc also give white precipitate, but it also dissolve in excess. So it cannot be zinc or aluminium. So we are left with only calcium. Other precipitates are colored. So this test confirmed that there is a calcium ion. And this give an idea that it's an alkaline solution or a hydroxide ion is there. To the third portion, aqueous ammonia was added. The solution remained colorless. So this
confirms the calcium,
calcium is there.
No precipitate found.
Good. Because the calcium, whenever you have a calcium ion, calcium does not give any precipitate with aqueous ammonia. So there is no precipitate, no visible changes there. So deduce the pH of a solution. What we can deduce, what we can say about the pH of a solution?
8 or 9 or 10 because it's weak alkali.
And identify the solid. So we identify it was calcium is there, and we identify so alkaline hydroxide is there. Yeah, it is fine. 11 also it's correct. 12, 13, 14 are strong. So it is calcium hydroxide. If you write it contain calcium ion, hydroxide ion, that is also fine. Or if you write a formula, that's also fine. You can write in words that it is calcium hydroxide. Question 9, planning experiment. We have a fizzy drink which contain carbon dioxide gases dissolved in a fizzy drink. The carbon dioxide gas can be removed from a fizzy drink by heating. Plan an investigation to find the volume of a carbon dioxide. Volume of a carbon dioxide gas in 1 decimeter cube of a fizzy drink. And in your answer, you should include how you will calculate the volume of carbon dioxide in 1 decimeter cube. And you are provided with a sample of less than 1 dm cube. Like you don't have 1 dm cube, you have less than 1 dm cube of the sample. So we have to plan how we can work out what volume of a gas is dissolved in this. So anyone want to answer how we can carry out?
We will take the sample we have and then heat it. And then we will also place a gas collection apparatus.
Okay.
Or we can reduce the volume of gas from the change in mass. And then we can conclude, like if we had 0.5 decimeter cube, we will have half the bubbles, half the volume of gas as in 1 decimeter cube.
Okay. But deducing a volume of the gas from the mass, it will be difficult thing. Like you have to do a lot of calculation, like working out the moles first, then. But directly, if you want to work out what will, so Yeah, you have to mention what you will take. Like you will take a specific, even 500 cm cube is too large quantity, like too large number. If you take 100 cm cube, you take 10 cm cube, that is also fine. So we'll take like example 100 cm cube of fizzy drink. By using measuring cylinder, always mention the apparatus which you are using, and we will transfer that into conical flask. So we took 100 cm cube of a fizzy drink, and then we transferred that into a conical flask. Why burette is not correct here? Because burette maximum can measure 50 cm cube. So if we are using burette, then we have to refill the burette. That will be a drawback. Like that won't be increase the accuracy of experiment if you have to refill the burette twice. So we'll take 100 cm cube of a fizzy drink by using a measuring cylinder, and we transfer that into a conical flask. Then we can connect the gas syringe and bung, or you can also say we can collect the gas over the water. That can also
We
be
can
done.
say
Hmm.
connect gas syringe via a delivery tube.
Yeah. So connect gas syringe and bung. Then what we'll do, we'll heat the fizzy drink until no more bubbles are there. Because then we won't measure the volume of a gas at that time, because the substance should cool down. Because if it is high temperature, if you measure the decrease in mass, that will give us the mass of a gas which is released. And then from mass, you have to work out the moles. So like you have to do multiple calculation. So to make it simple, we took 100 cm cube of a fizzy drink. We transferred that into a conical flask, like we have 100 cm cube here. Why we did not use a burette to fill this? Because burette we have to refill, as the burette won't be accurate. Then we connect a gas syringe, and we don't have to measure the rate here. So we don't have to measure the rate. That's why we don't need a stopwatch. So what we'll do, we'll supply the heat energy until the bubbles which are released here, like we don't see any bubbles formation. Then we wait the apparatus to cool down, because if you measure the volume at high temperature, it won't be accurate. So allow the apparatus to cool down.
Cool down to room temperature,
Yeah.
we can say.
And after, when it cool down, what we will do, we will measure the volume of the gas in 100 cm cube. Then the total volume of a gas is equals to volume of a gas times
10.
10. Why times 10? Because like we need for 1000, the total volume of a gas in 1000 cm cube, or which is 1 dm cube. That will be volume of a gas which we collect, and we'll multiply by 10. That will give us the total volume of the gas. Uh, why we don't need a time interval? Because we want all the gas to be released from the fizzy drink. That's why we are not measuring rate. We are not measuring how much time it will take to release of the all the gas. We just want to measure what amount of the gas is dissolved in this fizzy drink. That's why time is not needed here. And why we wait to cool down? Because when the operator, like example, say the temperature of a fizzy drink is 80. So at 80 degree, as we know, gases expands on heating. So if the temperature is high, it will expand. So the volume will not be accurate. So we allow it to cool down to room temperature to measure it. And we simply use the ratio, like example, if 100 cm cube say contained 2 centimeter cube of a gas, 100 cm cube of a fizzy drink, there was a 2 cm cube gas. So in 1000 cm cube, there will be X cross multiply. So actually it will be 10 times, because 100 into 1000, it's 10 times. So the volume will also be 10 times. So this will be 20. This is just an example. Is it clear?
Yes, sir, clear.
Yes, sir, clear.
Then question 10, two solids C and D were analyzed. Test on solid C was there. A flame test is done, and it give a red flame. What does give an idea about?
Lithium ion.
So
Lithium.
lithium, like you can see the flame colors here. So red is lithium. So this give an idea that there is a lithium ion. Then 5 cm cube of a sodium hydroxide. Look, group 1, 2 compounds, they like group 1 and 2 usually they don't give a precipitate, so there's no visible chain. That's why there's no precipitate form. Aluminium foil, like we add sodium hydroxide and then aluminium foil. This is now become a test for what? This is
Nitrate
Nitrates.
ion.
nitrate. So this is now a test for nitrate. And effervescence were seen,
Ammonia
and
is produced.
yeah, ammonia gas is released, and this confirmed that there's a nitrate ion. Because if there's a nitrate ion, when we add sodium hydroxide and aluminium powder or aluminium foil, as a result, if it's a nitrate ion and we add sodium hydroxide and aluminium foil and warm, ammonia gas will be produced. So this confirmed that the solution contained a nitrate ion. So name the gas.
Ammonia.
Ammonium.
So name the gas, that is right, ammonia is there. And identify solid. So we identify it was having lithium, and we identify it as nitrate. So it is lithium nitrate. Test on solid D. Solid D was aluminum sulfate. So they give you the name of a, sometime you have to state the observations and sometime you have to write the observation or write the test. So this contain aluminum ion and it also contains sulfate ion. D was dissolved in water to form a solution divided. Aqueous sodium hydroxide added, then in excess. If aluminum is there and we add sodium
White
hydroxide.
precipitate is
White
formed which
PPT
dissolves
soluble.
to give a colorless solution.
So if aluminum is there, it will give white precipitates, and which will dissolve to give a colorless solution. So here we will write white PPT, and it will dissolve to form colorless solution. Then aqueous ammonia was added to us, and then in excess. So if aqueous,
White precipitate which remains.
so here white precipitate insoluble in excess or remains, if that what you mentioned. So it will be white PPT, which is insoluble or in excess. Then nitric acid followed by silver nitrate. This is a test for halide.
Halides.
No halide, so no change.
So because they already mentioned it contain aluminum and sulfate, there is no halide, so there will be no visible change. And usually, so whenever, like example, if one ion is absent, then you will always mention no change. 1 cm cube of a nitric acid followed by barium nitrate. So it is
White
a
precipitate.
so sulfate. This is a test for sulfate ion, SO4 ion. So it will give a white PPT, a white precipitate. Question 11 table gives the boiling temperature of different alcohols are there: methanol, ethanol, propanol, and butane. One all. Why one all? It can be two all as well if the OH is attached with the second carbon. The apparatus shown used to separate the mixture. Name apparatus A and B. What we call A and B?
Thermometer
Thermometer,
and
and B round
round,
bottom flask.
round bottom flask.
So A is thermometer, B is round bottom flask. Add to a diagram arrow where the water enter and water leaves. You can use the screen annotation. Which side the water enter? So this will you will write in, and the other one you will write out. So water in and water out. Why is this not safe to heat the mixture of alcohol with a Bunsen burner? What's the reason?
Because
Flammable.
flammable.
Alcohol is flammable.
So alcohol are flammable liquid, can catch fire. So
Safely with hot water bath.
yeah. So how the mixture of alcohol can be heated safely? So we can use a water bath. Like we don't expose directly to the heat flame.
Electric heater.
Yeah. Electric heater. Describe how the condenser allow the alcohol to be collected as a liquid. So what is the purpose of the condenser? When it will produce vapors here in the
The
fraction.
vapors lose energy and condense
Yeah.
lose energy to the water in the water jacket.
So yeah, that's right. So condenser, basically what condenser will do, condenser will remove the energy from the vapor and form liquid. So how condenser allow the alcohol to be collected? Now you have to mention a reason for that here, like how it allow. You have to mention like it cools the vapor. Its change in state is already there because it's already mentioned it is condenses. Like in a condenser, it's already there. So it's just simple idea that it just remove the heat energy from the vapor. Which alcohol will be collected first and why?
The one with the lowest boiling temperature.
So which alcohol? Methanol will be
Methanol. It
methanol will
has
be
the lowest boiling point, so it will be
so it will be methanol
distilled over first.
right. So the methanol is there and it's having a lowest lower boiling point, so we can collect it first. Then another question related to identification of the ions. Solid J and K were analyzed. Solid J was a colorless solution. Colorless solution, what this give an idea? Give an idea like there's no non-transition element or there's no transition element present. And universal indicator was added. It gave a red color, so this give an idea that there is
From 0 to 2.
yeah, acidic solution is there. So this give an idea that H plus ion is there. When we add sodium carbonate, effervescence, lime water turned milky. So this confirm that it is an acid because acid plus carbonate gives the gas which is given off a carbon dioxide and a nitric acid and silver nitrate. So this is a test for halide, chloride, bromide, or
We
iodide.
have chloride because white precipitate.
So because it's a white PPT, so it's chloride is confirmed. So this given idea,
Hydrochloric acid.
hydrochloric acid. This given idea that acid is there. This given proton is there. This given idea chloride, so it's actually hydrochloric acid. So pH, like we write 1 and 2. Name a gas given off, that is carbon dioxide. Don't write the formula. When they ask name, then you should write the name. If they ask write a formula, then write formula. Then identify solution J. Solution J is strong acid, hydrochloric acid. The distribution of the marks, yeah, 1 mark is for hydrogen ion, 1 mark for chloride ion, or if you mention hydrochloric acid, you will score both marks. You can mention it contain H plus ion, it contains Cl minus ion. This will score 2 marks. Or you say hydrochloric acid directly, then you will also score 2 marks. Solid K was ammonium nitrate. So we have ammonium nitrate, means there is an ammonium ion and there is a nitrate ion. How we test ammonium ion? We add sodium hydroxide and heat. How we test nitrate ion? We add sodium hydroxide followed by
And then
aluminium powder,
aluminium foil, then heat
then heat.
carefully to
So
get
solid
ammonia.
K was dissolved and 1 cm cube of a nitric acid followed by barium nitrate. So what is the change here? Because this is
No
a
Nothing.
change because
this is
no
This is
a
for
sulfate.
yeah,
sulfate.
this is a test for sulfate ion, but there is no sulfate ion, so there is no visible change or no reaction. 2 cm cube of a sodium hydroxide was added to second portion of K. The mixture was warmed and the gas given off. So observation and the gas given
Effervescence, the
off is
gas given
tested.
off turns red, damp litmus paper blue.
Yeah, effervescence, bubbles, and how we test the gas. The gas was tested because ammonia gas is there, a pungent gas. Ammonia is a pungent gas, so you can say pungent gas. And what is the observation? Like how we test? We'll test with. You have to mention damp red litmus, and as a result, it will turn blue. In question 13, a black dye can be obtained from some plant roots. Plan an investigation to determine how many different colored substances are contained in a black dye from a plant root. You must include your result, how the results you obtain tell you how many different color substances. You have access to plant root. So you have plant roots now. First, what we will do?
We will
Crushed
grind
by
with
That's
mortar
pestle and
and
using
mortar
pestle.
pestle and mortar.
So we'll
and then
crush.
filter it.
Yeah. After crushing, add a solvent like
Water we
uh,
can.
yeah, water you can
Salt or
mention, and
salt.
then
While
fill.
heating.
Yeah, heat also so that you extract the maximum amount. Then using a dropper, you will place a liquid on a chromatogram, then
The
conduct
baseline.
chromatography. Yeah, draw origin with
Then
pencil.
immerse the chromatogram in the water, in the solvent, but under the baseline.
Yes.
So we'll place a sample and we'll have a solvent, allow the solvent to rise on the chromatogram. And how we'll know how many colored substances are there? The
The
number
number
of
of
the
spots on the
number of spots
Number
shows.
of spots.
Clear? So this was, I think I have already discussed this once before.
Yes, sir, in exam.
Yeah, the test. So I'm not writing. If anyone want me to type, so I'll type. Otherwise, I'll move on to the next question. So question 14 is there. The student investigate the dyes contained in different colored inks using the chromatography. The water was a solvent. The diagram shows how the solvent set up in the apparatus. Identify two mistakes.
The solvent level is above baseline.
Good. And what
And the
else?
baseline drawn in ink.
Yeah. So baseline
Yeah.
drawn in ink and the solvent level is above the baseline. That these are the two mistakes. Like this is first and this is the second mistake. Then the diagram, the student then carried out the chromatography correctly, and the diagram shows the result of the experiment. Which ink contained the greatest number of soluble dyes?
Black ink.
Yes.
So how you identify black? Because as you can see for black, how many spots are there? 3. For purple, 2 spots. Blue, 1 spot. For green, 2 spots. 1 spot, 2 spots. So black is having the maximum number. That's why greatest. That's why we say black. Which two inks are made from a single soluble dye?
Blue and yellow.
Yellow and blue. Because like a single soluble dye means it is giving only 1 spot. So blue and yellow both are giving 1 spot. From a chromatogram, it is not possible to tell if the red ink contained different dyes, how the experiment changed. Like
Use
what?
different solvent.
Use different solvent in which the red can dissolve. Because right now, the solvent which we are using, the red does not dissolve. So we will change the solvent. No, actually, what happened, the spot of the red remain on, not about locating agent because it is not that spot is not visible. It's the idea is that the ink does not even rise with the solvent. So if ink does not rise with the solvent, what we should do? Like if we're using a water, then we'll use alcohol, then the spot will rise. So adding a locating agent is not correct because they did not mention it contain colorless substance. And it's a red dye is there. So what we simply do, we'll change the solvent, use different solvent to extract, to obtain this chromatogram. Then this question, G and H were analyzed. G is a copper 2 carbonate and G was placed and sulfuric acid is added. What is the observation if we add sulfuric acid to?
Effervescence
Bubbles and the
the gas
decrease in
produced
size.
turns lime water milky.
So effervescence, phase, bubbles, effervescence, and the lime water turn milky.
It is a test for carbonate
Yeah.
and adding dilute acid.
Right. So, and then identify the gas which is produced.
Carbon dioxide.
Then the gas produces carbon dioxide or CO2 is there. Aqueous ammonia was added. So if we add aqueous ammonia to copper salt, so observation, it will be blue
We
precipitate,
will get light blue precipitate dissolves to
dissolve,
give a royal blue solution.
royal blue solution. Royal blue solution or inky blue solution or dark blue solution will form. Then H was there. A flame test is done. So H is giving.
Sodium
So
ion.
it's sodium.
So yellow flame give an idea that there is a sodium ion. When we heat, condensation appears. So this give an idea that it is
This is hydrated crystal.
hydrated. And nitric acid followed by silver nitrate solution remain colorless. So there is no halide, no chloride, bromide, or iodide. And nitric
There is
acid,
sulfate.
there is a sulfate. So
Sodium sulfate.
what conclusion you draw about test 3? So test 3 means
Solid
there is
H is not a halide.
no halide is there. Yeah, group 1 salt can be hydrated, can be anhydrated, and the salt is sodium sulfate. It's not a rule that group.
Hydrated sodium sulfate.
So yeah, hydrated sodium sulfate because 3 marks are there. So I have to mention it is hydrated. 1 mark is for sodium, 1 mark for sulfate, 1 mark for hydrated. So this was question 15.